Thanks, Matt, for that very kind introduction. And as he said, my name's Carla, and I lead the network research team at Protocol Labs. PL builds tools to move science forward faster, and we consider these tools an important public good. The network research team, in particular, identifies leverage points within science as a system. So here I'm calling back to Donella Meadows, one of our favorite writers and thinkers, to align researchers and research funders. We're a member of the PL Network Goods organization. I have the pleasure of working closely with Matt's team, among others, on their various initiatives and being a first consumer of a lot of their products, of their meta-research products. And we take, within the network research team, we take research as our model system and our workspace for creating research-flavored public goods. So even better than bacon-flavored public goods. And so today, I'd like to tell you a little bit about our MetaScience Toolkit, the tools that we're using to align researchers and research funders to drive breakthroughs in science and accelerate the discovery innovation cycle. And I'd especially like to highlight how we're using them together in combination to build new tools and initiatives. I will be speaking about 5 meta-research tools in particular. I'll start off with a brief description of each tool, how it's being used and by whom, and how it can be combined with other tools. I will describe some of our active and recently completed initiatives that we're using running these tools. And finally, I will describe how you can get started using these tools and incorporating them into public goods building workflows and initiatives. And first, I'd like to introduce our team, because later on in the talk, I'll be inviting you to join us, either formally or informally, if the work I describe appeals to you. So myself, I am broadly interested in anything that can be plausibly represented as a graph, and I'm beginning to think in discourse graphs. That's one of the tools that I'll be talking about later. My colleague Sylvia has a background in bioengineering and computer vision, and she's leading our research road mapping efforts. Ray is our startup operator and entrepreneur in residence. He has a background in privacy-preserving technologies, and he's particularly interested in developing or uncovering grand challenges in Web3 research. Our advisor, Bharath, has a background in distributed systems writ large, with a particular emphasis on revolutionary internet architectures and computing for social good. So now you have conversation starters for all of us. And Bharath, he's not here, but if you ever do get a bit of his time, you can talk to him about anything, including like pineapple horticulture. So, and now on to our toolkit. Network research, as I mentioned, is currently focusing on 5 tools that we call our meta-research toolkit, our meta-research primitives, because of their modularity and their composability, their ability to be combined to fashion new tools to support various kinds of research initiatives. So I have previously referred to these tools as Lego bricks, but today I'm going to switch up my mental models and refer back to a popular 80s cartoon, or anime for you Zoomers, that just got a modern reboot. That's Voltron, one of my favorites. Voltron, as the more cultured among you may already be aware, is a type of self-assembling mecha, or giant robot. It's composed of 5 independently piloted and super awesome robot lions. There is, of course, a second Voltron mecha composed of vehicles, but we shall not speak of this today. It's lions all the way down. So we like to think of each one of our meta-research primitives as a flying robot lion, powerful and complete on its own, but even more awesome in combination. And that's my metaphor, and I'm going to stick to it. So, on to introducing our lions. They are discourse graphs, research roadmaps, hypercerts, blue funds, and impact evaluators. And I'd like you to note that, of course, I got the blue funds to line up with the blue lion. That's the highlight of this talk in terms of visual design. First off, discourse graphs. A little bit of clapping there. Thank you, thank you. Discourse graphs are a tool for synthesizing and sharing information. They simplify scientific communication into its constituent parts, and they allow researchers to exchange ideas with greater granularity. And why are we focusing on a new form of scientific synthesis and communication? Well, right now, a lot of scientific communication is siloed in PDFs. Papers are a slow way of sharing scientific knowledge. They're a clumsy way of sharing tacit knowledge, like experimental design. And they're not necessarily the best blocks for knowledge synthesis. They're already partially put together, they're largely composed into a narrative, and they're harder to break apart. So why not have a scientific conversation that resembles a conversation? And here I should emphasize, I come here not to replace the PDF, not to replace the scientific manuscript. I think that discourse graphs are a nice addition to the ecosystem of scientific communication forms. It's more of an analog to a preprint than it is to, say, a letter to nature. But I think it plays a very important role in scientific communication and, of course, in our development of our thoughts and ideas. A little bit about the data model of discourse graphs. The structure of a discourse graph emphasizes discourse moves, the parts of a living conversation that we're all familiar with. Moves emphasizes the dynamism of asking questions, making claims, attaching evidence to those claims, and if you're lucky, pointing toward a source for that evidence. This is not true, of course, if you're arguing on Twitter or on Reddit, but ideally, in terms of scientific communication, we provenance our claims. These are the nodes of our graphs. And the relationships between these nodes, the edges of our graph, these are the relationships between these discourse moves. So you have evidence informing questions. It can support or oppose a claim. Claims can support or oppose other claims, and new questions can be informed by existing claims. And this is a very important part of the discourse graph idea model. It's highly generative, and it helps researchers find new questions. These edges and these nodes together, they form a data model, weaving together our open research questions, our ideas about the world, specific observations that those ideas rest upon, and the sources of those observations, all woven together in a flexible framework. I like to think of discourse graphs as sort of GitHub for synthesis. They support and incentivize knowledge sharing at all stages of the scientific process by making it easy to push and pull from a shared knowledge graph. And of course, you control how widely and how broadly you share your graph, your knowledge graph, and allow researchers to claim credit for many more types of contributions. So they're a partial foray into the value attribution question that plagues a lot of scientific research ecosystems. So thanks largely to the work of researchers like Joelle Chan and Matt Akamatsu and the same page development team that's working on the interoperability layer for discourse graphs. These are projects Network Research is pleased to support and have supported. Discourse graphs can be implemented in several network notebook softwares like Obsidian, Logseq. Of course, there's a discourse graph extension for Roam Research. That's probably the most widely used discourse graph tool. But you can do this in a Zettelkasten system. You can do it on a murder board. It's highly flexible. It really is a protocol for communication, a protocol for synthesis. So who's using these tools now? Well, there are hundreds of active discourse graphs with deep engagement. And to give you a sense of the extensibility of the protocol, the partners and investors at Deep Science Ventures are using discourse graphs to develop and de-risk venture creation initiatives. So you can do anything from research road mapping, knowledge synthesis, venture checking. So in the realm of the laboratory sciences, a realm that we're particularly interested in, there are now discourse graph-powered lab groups at research organizations like the Allen Institute for Cell Science and the University of Washington Molecular Biology Department. They're using a discourse graph dialect that researcher Matt Akamatsu, who is a molecular biologist himself, developed to better reflect the language of experimental science. He calls it the results graph. You can see the difference in terms here. The questions, claims, and evidence, which would normally be derived from written sources in a synthesis of scientific literature, in a literature review, are now the hypotheses, conclusions, and results that rest on experiments. And the, I think maybe no? We'll just go with that. So the results graphs, they're not just a simple renaming of the protocol. They emphasize the experiment, the model, the simulation as the source of truth, and they make it easier to formulate requests for experiments. And one of my claims is that a hypothesis is essentially a request for experiments when you see a gap in the data that's needed to substantiate a conclusion or to test a hypothesis. Making these requests of the scientific community is an important part of road mapping a scientific initiative. And so that's a nice segue into our next research primitive, research roadmaps, which work well in combination with discourse graphs, just like our friends at Deep Science Ventures are using them. A research roadmap, what I'll call it, is a goal-centered model. It describes significant milestones and their relationships. It concentrates expert attention on a scientific problem, which enhances discovery. It identifies leverage points so that we can choose higher impact projects and actions. And it drives distributed coordination. It empowers researchers to make informed decisions about how best to reach a shared goal state and shape their work accordingly. So we think of it by combining discourse graphs and roadmaps as creating a user interface for distributed coordination. The knowledge synthesis process helps us to understand the current state of the art, relevant to the goal state, and identify dependencies, missing stairs, missing milestones, and links among the milestones. And then the modular, sort of composable structure of the discourse graph helps in finding possibilities to re-architect or recombine existing capabilities. How do we build a roadmap? We identify a goal state. We identify desirable probabilities or necessary characters of that goal state. We draft open problems for creating these properties. And we suggest potential directions for solving these open problems. So building a research initiative with discourse graphs, you can see that each node of the roadmap is itself supported by a discourse graph. That's where the composability comes in. And as you build your roadmap, you and your collaborators are having discussions or even arguments, not quarrels, arguments. What is the desirable goal state? What properties are essential to reach the goal state? What research projects are necessary to reach or enable those properties? And what are the highest impact directions that you can take within these projects? So again, composability, there's almost a fractal exhibit to discourse graphs. I almost dropped in one of those exhibit means here. I hear you like discourse graphs. I put a discourse graph in your discourse graph. It's discourse graphs all the way down. They can be dropped in at different points on a roadmap, and they're largely scale independent. You can use them to build out initiatives of different sizes. And so this is where it becomes interesting for aligning researchers and research funders. You're basically creating an investment thesis for each funding decision that you make and opening it for evaluation by aligned co-funders by the scientific community at large. And with queryable discourse graph-based roadmaps, you can make your arguments quantitative. So a lot of these software implementations, they support graph-based queries, they support quantification of certain things, assigning your own networks or parameters, metrics or parameters or features to each particular node, creating your own attributes, so you can really make this a powerful system for query and analysis. And this makes research roadmaps a good framework for discovering and attaching resource funding opportunities like those that Matt mentioned. We have a whole toolkit at our array from hypercerts to blue funds, prizes, grants, bounties, and that leads us to the next of our lions, the hypercert, a new research funding model. So a hypercert is a particular impact certificate implementation. There will be other, better talks about hypercerts that will really let you hear this lion's roar. But here we'll focus on how hypercerts incentivize and support the creation of research impact. We think of hypercerts as an interoperable data layer that encodes impact claims and makes impact transferable. And from our position, our perspective as researchers, we think that they stimulate high-impact research by enabling researchers to pull funding forward from the future in the same way that for-profit ventures and capital markets can. So right now, research is funded via grants, bounties, and prizes, but these methods, they have different risk profiles. They shift the risk either to the researchers, incentivizing them to pursue safer research projects, or to salami slice their research, or to write the grant for the research that they've already done, all these tricks that we all know. Or they shift the risk to the research funders, incentivizing them to solicit safe, low-impact research. Or in the case of prizes, they might force researchers to be able to fund their own operations just because of the timing of the release of funds. These all have their place in the research funding ecosystem, but we want to have a different model that has a different risk profile. So potentially high-impact projects with a higher chance of failure are less likely to be funded over many of these models. So when we add retrospective funding to the research funding system, allowing final funders to pay only for successful projects, that makes them a little bit more risk agnostic, and it allows a more low probability, high risk research to be funded. And this is possible because our system includes, I have a laser. Oh, maybe I don't have a laser, darn. Prospective funders who specialize in building research project portfolios, and they can be rewarded for the impact that they buy from researchers by final funders once that impact has been realized. So we see an obvious connection between research roadmaps and hyper-certificates. Research roadmaps can be used to transparently and iteratively align researchers and research funders about the feasibility and the impact of a solution, and to estimate the cost of a solution. Remember that quantification aspect. And this can help in price discovery for impact certificates, as well as attracting final funders to pre-commit resources on the path to the goal state. So we've talked about how research roadmaps can be used as a discovery tool for locating potential impact certificate attachments, sort of impact, areas of impact. And I'd like to briefly touch on the role of discourse graphs in the system, which I've hinted at. So a hypercert, if we think of a hypercert as an interoperable data layer encoding a claim that a certain initiative will produce a certain impact, a discourse graph can be used to support that claim. So you can embed it at any point. It can be embedded at the point of impact evaluation. It can be part of the claim made by the researcher. It can be part of the evaluation mechanism of the funder, the seed funder, who's considering funding that research project. So the quantitative aspect, again, can help to de-risk impact certificate purchases for prospective funders and increase the visibility of projects needing seed funding to make an attempt on the goal. Our hypothesis is that creating a deep bench of impact certificate possibilities drives discovery. When innovators know that there's desire, there's latent demand for their work, they're more likely to embark on projects with a different risk profile than standard academic research, including those with a lower probability of success. So a deeper bench of funders de-risks these projects for researchers. The seed funding decisions are somewhat de-risked by the research roadmaps, and that allows them to assign more accurate probabilities of success and de-risk their research bets and build a stronger portfolio. And if they have a stronger portfolio, hopefully they can stay in the game longer, continue to regenerate these flows, and to make more research bets. So this, we hope, will create a virtuous cycle. We're getting a little bit green-pilled here. I'm going to move on now to our next lion. So we've introduced impact certificates to the research ecosystem. So of course, now we need a way of assessing impact. If you saw in that systems diagram, we have an evaluation step. Well, how do we carry out this impact evaluation? So an impact evaluation is, different kind of impact, but I think you get the idea. It's a method for retroactive funding that rewards projects based on the impact achieved against a set of goals or KPIs. It's a tool or a process that can assess the value of a system's output and use this assessment to make improvements to the system itself. Again, there will be better talks about impact evaluation. I just want to show you how it works in this particular framework. Within a research ecosystem, the goals of an impact evaluator are to signal which projects are valuable, so you get more of that. You pay for something, you get more of it. And it provides incentives to tie outcomes to incentivize outcomes rather than just work, rather than just activity. So there are lots of different types of impact evaluators, and you'll hear much more about this today. You can build a lot of different types to fit your particular use case. Within research, we can think of a couple ways they might be used. Let's say you're retrospectively assessing the impact of a research initiative. You might assemble a group of domain experts to carry out a discourse graph-based quantification of impact according to certain agreed-upon metrics. Maybe for a competitive research implementation initiative, you could ask those same or relevant experts to vote on the highest impact contribution to a repository or some other project via quadratic voting and attach quadratic funding to that. Lots of possibilities here. So how is this an improvement over over current art, over prior art. So right now, impact evaluation in science is largely carried out using various citation-based metrics. They privilege manuscripts published in high-impact journals. And this does actually accurately capture certain aspects of research impact, but it's incomplete and sometimes misleading. This particular image is meant to refer to the idea that the impact factor of a journal and the impact of any paper published in that journal are largely independent. They actually don't correlate as much as you might think. So we think that combining specialized impact evaluators that can be tuned to capture research impact at different timescales and via different research artifacts, so maybe you push some code, maybe you create a visualization, maybe you run an experiment, maybe you create new reagents, combining that with discourse graphs, which can highlight more granular contributions to research efforts, we can incentivize research contributions that are currently undervalued and shift the incentive field toward high-impact research. So now we're talking about incentive fields. We've talked about one funding method. I'm going to go on to our blue line, blue funds, because this is something that we use a lot internally. It's a little bit of language. It sounds like inside baseball. I'd like to disambiguate it a little bit. Blue funds come from the whole idea of research projects being blue, development or productionized projects being green, Juan's metaphor of the innovation chasm. So blue funds are established to pay the cost of ferrying projects across the innovation chasm. We pay the ferryman with blue funds. And there's, I guess, a bit of a negative valence to that whole idea. He's not Charon Death going across the river Styx, but it is a dangerous crossing, and we do need to pay projects across this dangerous river. Blue funds are customized, they're flexible, they're composable. It's a service that we provide to the network where researchers, engineers, interested parties can come to us, can provide us with a research artifact, a paper, a talk, and use that as a platform for creating a research initiative. That research initiative can be funded via various mechanisms, which Matt and his team of funding wizards develop. We write the open problems, we might draft a roadmap, we create a viable initiative that can attract attention and eyes to the problem, that states the problem clearly and pushes it along the path toward funding. So I've introduced all of our research lions. They're in a pack, they're hunting in a pack, but I didn't mention the giant flaming sword. And that might seem to be a little bit of, like, what, you've got all these lions, but the sword, what's missing here? What's missing is you. This is where you come in, our community, the decentralized science movement and the public goods builders. You're our greatest weapon, our Voltron Mecha's flaming sword. And if supporting this kind of tool building, if using these tools and creating new incentive mechanisms for research is your jam, consider working with us. The network research team is hiring research scientists to help work on the value attribution process, to help evaluate different ways of estimating the return on a research investment, to better understand research networks and how they work together, to better understand how we can elicit truthful predictions about the viability of research paths. We're hiring research program managers who are interested in building a portfolio of research initiatives. And we're hiring a research communicator who wants to speak to the public and to our community about this research and translate it into terms which are broadly accessible to the public goods community. And that's on the formal side. We are also supporting, you can see the other QR code, that's a link to our current grants portal. You can see what we're working on now. There will be more additions using additional mechanisms in the future. That's a great way to keep an eye on what's top of mind for the PL network. Completely not a non-exhaustive list of possibilities. There's always RFPX for you to find your own research program. And then, of course, we have a discussion server, a Discord server for research nerds. It's completely public, completely open. We talk about meta-research, tool building, and a lot of the people who think deeply about these issues are there, just waiting, lying in wait to ambush you with questions, ideas, and to build off of your energy. So thank you very much for your time and your attention. And I think I have a little bit of time for questions here, if there are any.
Hi, can you hear me? Yeah. Thanks so much for the presentation. I think this is what I came here for, so thank you. You made a comparison about discourse graphs being like a GitHub for synthesis. And I wanted to ask you if you have a position or an opinion about how open research should be, and how soon it should be open or not, and if that's embedded in the tools that you're building.
That's a really good question. It's a difficult question because, of course, I would like to say we like to work in public. We have an open source ethos. All of our grants and everything come with the only thing we ask of our recipients is that you work in the open. That any code or products that you produce are published under open source licenses, published openly, open code, working transparently, yada, yada. However, I do have to recognize, thinking in terms of incentives, is that not everybody is similarly situated to work in the open. That academic incentives, the academic incentive field sometimes inhibits folks from feeling comfortable sharing their research. So early career researchers may have real good reasons not to want to work as transparently as more senior researchers. And I can't hold that against them. That's a systemic issue. So what we want to do is shift the incentive field to encourage, to make it comfortable, to make it the best choice for people to work transparently. How this applies to discourse graphs, I expect that persons will curate their own graph and they will decide on how transparently they wish to work. I think some of this is their willingness to share their ideas, but more of it is their ability to inhabit the same context, to have the same common knowledge of people working on a shared graph. I don't think you can have one global graph. I think we will have multiple graphs or multiple views on larger graphs. I think it's great that these graphs are interoperable, and that's why I think the GitHub model works here. You can observe a graph. You may not have write access to it, but you could potentially fork it. You could clone it, and then create your own graph based on other people's work. So I think that is the level of openness and transparency I think people in the current research ecosystem are comfortable with, and that's where we will meet them and hope to nudge them to sharing more broadly and building a larger ecosystem.
I'd like to know, where do you see some Web3 specific technologies making the greatest impact here? I mean, there's a clear link with I guess, Filepoint and decentralized storage because data is so important. But in terms of, are there other things such as tokens or incentives? Your personal opinion on where Web3 really fits in specifically?
Part of the Web3 fit to these ideas is just the ethos, the idea that things are permissionless, that you start building, that you create and curate your own community, and that there are no centralized gatekeepers to knowledge, to access to services, to tools. Things can be disseminated much more widely and much more broadly. The other part of the Web3 ethos that's important here is the idea of censorship resistance, the idea that a lot of these tools, the composable nature means that they can be sort of replicated widely, stored in different local first, broadly shared, locally shared repositories. They can be operated and worked upon by multiple communities at once, and nobody can sort of cut the pipes and stop the work. In terms of tokens and other specific forms of incentivization, it's clear that we definitely have, as Matt said, a really exciting testbed and playground in the Filecoin network, in IPFS, for working on these incentive mechanisms in a very concrete way, using, well, as concrete as a blockchain can be. We consider it the real world, our real world. We have certain affordances at our disposal that traditional research funders don't. So we definitely see this as a new space, kind of a blue field, where we have the latitude to experiment with new ideas and new mechanisms in a semi-controlled, open and transparent testbed.
Hey. So I guess one of the things that's coming up for me here with all of these graphs is the semantic web and the promise that holds. I'm seeing that there's a large amount of metadata that can kind of correlate across different contexts, which feels promising. And I guess I also see Protocol Labs as kind of having the funding to catalyze such a community of practice. And so, yeah, I'm just wondering what your thoughts around that blue field looks like.
Yes, you've really pointed to a very exciting opportunity here. The idea of the interoperability between a lot of these different things that we've been speaking about, the fact that this can map, imagine that you did a discourse graph and you assign CIDs to different nodes and you can capture particular metadata which is not just used for surveillance, but which is informative, which can be used to, say, track contributions to a graph, to attack the value attribution problem, to provenance certain ideas, to see how ideas evolve over time. So yes, we definitely see a mapping between these types of tools and the technologies that we have at our disposal. And one of the things that we'd like to work on is developing open source, free implementations of a lot of the tools that you see here, so that we can invite other people to, again, fork and hack on these tools in an open way, experiment with Web3 frameworks to support these tools, both internal and external initiatives around these tools, extremely welcome. We are very receptive to any type of grants or any type of research initiatives, any type of research proposals along these lines. Well, then, thank you very much. I really enjoyed my time up here.